Can you also explain how do LLMs work? How does just for everyone's understanding, right? Like, how is it operating? How is it giving us these answers? How is it generating images or consuming images?
Right. So I think maybe we should start with how AI works
Sure.
in general. And there are sort of various paradigms: supervised learning, machine learning, and deep learning, transformers, the T of GPT, and stuff like that. So all of that is and LLMs, large language models itself, right? But one basic thing about machine learning, this term, is that machines learn pretty much like we learn or humans learn, right? How do we learn? We learn through association. For example, we are taught, we are showed, in our younger days, apple would be shown or drawn on the book, and somebody will say that this is apple, right? And you'll make an association that when something red of this shape, that is apple, right? In some other Hindi mein wo seb hai. So you associate that seb is associated with apple, is associated with this something which looks red of this type. Now this training process, and these are all technical terms also, right? You train a model, or the machine learns, is actually similar. How do you train it? You give it hundreds of images, for example. Let's say a COVID X-ray, chest X-ray, and you have to determine whether it has COVID or not, right? How will a radiologist learn? They'll see several
other X-rays.
They'll see several X-rays. They'll say this is COVID, and you'll also see some maybe the tough cases which are on the boundary, right, or which are confusing, which is actually something else. It is TB, but it looks like COVID. I mean, I'm making up random stuff, but that'll come in the exam like a tough question, right? So you also need to train the AI with such tough cases. Actually, they are more important. It's not the amount of data. And this is called labeling, right? You have to give it answers initially. In supervised learning, supervised means you give it answers. So you say that this is apple, this is also apple, this is also apple. This, by the way, is not apple.
But it looks like
it looks like, it is red and almost that shape, but there's some other reason, because that is when it learns the best, right? It learns the most. You'll give it 1,000 such images, let's say. If it has a lot of diversity, then 1,000 is enough. If you're giving the same apple ka image and no challenging cases, even 1,000,000 images are not enough.
That's
right?
True.
So, because we often discuss, you need a lot of data, right, to train these. So more than the amount of data, the diversity of data. Right. Now, this is how AI learns, right? And most of AI is machine learning based and supervised learning based, means learning through association, you give it answers, this applies. There are also things around unsupervised learning where you don't have to, because giving answers is a manually intense exercise, right?
And GPT and LLMs are all unsupervised, I'm assuming.
Yeah, largely unsupervised, but a lot of supervised stuff has also gone into it, right? Both these approaches have trade-offs, because unsupervised requires a lot more data typically, and it will require a lot more compute. So training a model, this learning process is very compute intensive. So all your GPUs and infrastructure of the world goes in training. It is relatively less, you don't require too much compute for inferencing, which means when you have learned it, now you're going to ask the question, is this an apple? You'll show a new image and say, what is it? That is the inferencing time, right? You're no longer training ho gayi hai, now you're answering. That is not compute intensive, right? Of course, if millions of people are asking, or billions of people, then that gets multiplied. But one instance, at least compared to training, however, is very compute intensive, right? And data intensive also. So, unsupervised learning requires more data and more compute typically. So there are trade-offs, these kind of trade-offs between the two, right? I think this is also a good time to talk about foundational models. So LLMs and foundation, ChatGPT is a foundational model, right? What and there is debate, by the way, in terms of where do you draw the boundary between a foundational model and a not foundational model. But foundational model is something which can do a large number of things, large number of diverse things. A chat GPT, you can give it a medical report, you can ask your personal questions, you can ask where to travel, you can give your financial reports perhaps. There are n number of things that you can ask it to do, right? And it is sort of one model which is answering that. That's what. So basically, the foundational aspect means it has kind of foundational knowledge. It has everything, and you can ask it anything, and it'll answer.
Like an encyclopedia, basically.
Like an encyclopedia, and there are foundational models, for example, in ophthalmology, which will answer everything to do with ophthalmology. However, it is akin to a general ophthalmologist, right? But you may have specific models for something very specific, right? Like driving a car. That model will only be able to do that. If you ask it to generate an image or something, it may not be. It will not be able to do it, but it may be the right solution. So foundational models are not the optimal solution for everything. But we need to, the important thing is to separate these two, right? Now, if we come to LLMs, finally, they are a particular type of algorithms, right? So large means large amount of data has been used. They are probably foundational ChatGPT type of stuff. Language is because it deals with language. At least it started with conversation. NLP or natural language processing is what we call it, right? By the way, technically, now, for example, in images and videos, there's something called VLMs, vision language models or something. So there are other problems which are not conversation related, but from a mathematical and structure perspective, they are similar, right? So you reduce some of the other problems to LLM type of setup, but principally, when we say LLMs, they are dealing with language, right? So they don't apply to things which are not language related,
like
which
images
are not
or videos.
Like images or videos directly, right? There might be other algorithms. So LLM is just a type of AI, in particular optimized or made initially at least for language, right? By the way, another interesting thing about AI, which relates to LLMs in particular, or conversational AI, the kind of things for which we use our brain explicitly, like when you have to multiply two numbers, right? You explicitly use your brain. When you have to talk as humans, it comes naturally, right? It comes from your spinal cord, perhaps, or it is hardwired, right? You don't have to apply or exert yourself. So these second type of things, which we find easy, which are natural, which are inbuilt, are the ones which AI has conquered or is conquering later. So it is in a way more difficult. For example, walking, like a robo walking is, we just walk effortlessly, right?
Yeah.
There's a lot of computation probably going on inside, of course, but that evolution has built into our brains and spinal cord. So this natural language, you would remember we had IVR systems, etc., which sounded very robotic, and it'll give you 5 options and you have to choose from one of those 5. The disruption really right now from LLMs is about that it is natural and it is unstructured. And this is an example of the general category that I was saying, problems which we do effortlessly without thinking. Because, a calculator was invented, I don't know, 100 years ago. That does the brainy part, right? Where you have to explicitly do things, and many other things like that, which are structured, logical problems. But kind of things which we don't think about, they turn out to be more difficult. But now the advances in AI and in particular LLMs are about that, right? So hopefully this gave you some idea of
for sure,
how AI works and how LLMs work.